What's up? Sorry, I got tired of saying aloha every day we get this thing started. But here we go. We go to section 3.5 right now, which is derivatives of trigonometric functions. So if we're associating this to our AP curriculum, it'd be topic 2.7, where we introduce cosine, sine, and we actually do tangent, secant. We do everything today. Okay, and why do we do it right now? And we kind of put 3.4 after 3.5 is because we use a lot of trig functions with our rules of the quotient rule and the product rule. Okay, so let's get after it. Okay, but there you go. You can take a look at that and see what we're doing right here. Okay, but we kind of get this unit started with a little bit of a warm-up. Okay, what I want you guys to do is we have these warm-ups right here. Let me get my pen here. I'm using my finger this time. We better know this bad boy. The limit as x approaches 0 of sine x over x is equal to 1. Okay, this guy I want you to put in your calculator, and I want you to tell me what the limit is. Okay, and then I want you to do 3, and I want you to do it algebraically. And when you're doing it algebraically, what I want you to do is use this idea of conjugates. I know that there's not a square root on the top or the bottom, but believe it or not, you can prove this with this conjugate idea. And then I'm going to magically, after you give that guy a shot, make sure you give it a shot, challenge yourself a little bit, hit pause in a moment, and then I'm going to have the answer on, okay? But hit pause right now, and let us see how you do. Hint, you're going to have to use some Pythagorean identities that you learned in pre-calc. Booyah! There's our answer right there, okay? So you multiply it by the conjugate. Let me get my pen going here on the screen, which is that bad boy right there. You get this result. That should be a little bit familiar. Now, what they did, and I'm using my finger here, you guys. Let's get this pen. Okay, where you use sine squared x plus cosine squared x equals 1, right? That's the most famous Pythagorean identity you've used. And if we bring the cosine over there, that's how they get that sine squared x. If you were able to get this on your own, unreal. And then you have an x down there, you've got a couple signs up there, and so if we organize it correctly, booyah, answer done. If you're able to do that on your own, unbelievable. If you had trouble understanding that, please bring it up in class and we will go over it in class. All right, now I'm going to go ahead and move this bad boy up. There's a couple of things here. We're not going to get crazy and do this, okay? But if you look here, we could find the derivative of sine x using the original definition of the derivative, where you have to remember your sum and difference for sine, and then all of this awesome magic happens. You do not have to be able to do that on your own. But it's kind of cool to see how that works itself out. Should you be able to do something like that? You should, okay? And once again, this is just tying pre-calc and calc all together, okay? Original definition of the derivative, using the sum and difference for cosine, working it out, moving things around, and able to get an answer. Kind of really cool how that happens. Now, what you better be able to do, something that I would expect you to do, is could you do it for something like tangent? So we will do it right now together, okay, class? So we're going to take the derivative with respect to x of tangent x, okay? And we don't know it yet. So what we're going to do is we just did sine and we just did cosine, right? The derivative of sine was cosine and the derivative of cosine was negative sine. So what we're going to do here to help ourselves out is we're going to turn this into the two that we know, which is sine x over cosine x, right, class? Because that's tangent right there. Okay, now, oh snap, that's a quotient. Sweet. So let's do the little derivative of a quotient would be low. So we write down the low times the derivative of the high. And the derivative of sine, let's see, we did it there in example 1. Derivative of sine is cosine x. Okay, and then it's minus the high, which would be sine x, times the derivative of the low. And the derivative of cosine, what was that again? Oh yeah, negative sine x. It's right there in example 2. Hopefully you took that notes. Over low. Or the cool way to write that, right, class, would be cosine squared x on the bottom. All right, let's do a little simplification here, right? Sweet equal signs going on. Cosine times cosine is cosine squared x. A negative, two negatives, snap. That's a positive. So we get sine squared x all over cosine squared x. Oh, snap. We just did this at the beginning of the day, right? I wrote that down for you guys. And cosine squared x plus sine squared x is 1. 1 over cosine squared x. 1 over cos. Oh, that dude's got a cousin. That's secant squared x. Boom. Guess what the derivative of tangent is, class? It is, booyah, secant squared x. Okay? Here we go, class. I usually say don't memorize, but you better have those bad boys memorized when you walk in class tomorrow. Okay, if you don't have those memorized, it's going to be real tough to do well in this chapter, okay? Here we go. Let's do some examples. Like I said at the beginning of the lesson today, the reason why we do 3-5 right after 3-3 is bang. That right there, right, class? That's a product. Now, how do we take the derivative of a product, okay? Let's see. How do we take the derivative of a product? We have a u and we have a v, correct? So we rewrite down u, which is x squared, and then here, I'm going to do it the long way. And you don't have to do it this way, okay? But I rewrite down that first guy, and then I take the derivative of my v. Okay, and this is just writing down the work. Plus, okay, now I write down v, and what do? I take the derivative of u. Okay, and you do not have to do that step. You can go right to this step right now. Okay, that'd be x squared, and the derivative of v is cosine x. Boom, done. Plus sine x. What's the derivative of x squared? It would be 2x. Okay, and then I could just, you know what, usually we just like to write these in the same order. Okay, so if I'm going to put the polynomial guy first, put it first in both of them, and put the trig guy second. Okay, some students, what they do is they end up factoring stuff. Why? Why? We're not asking, we're just asking you to simplify, right? If I factor, I'm technically going backwards, okay, class? Here we go. I'll leave that on the screen here for a brief moment. I'll go to this next guy. Sweet, that is a quotient rule. All right, I'm going to do it long one time. Okay, you do not have to do it this way. But in case anybody's a little bit confused, I'll make sure I write down exactly what I am doing. It's a low. So I rewrite the low. And then we take the derivative of the high. Okay, minus the high, okay, times the derivative of the low. All over, low. Okay, so I'm going to do that guy. That'd be low. Now, once again, you can just go straight to this step, okay? That's equal to, let's do it again. The low times the derivative of the high, which would be negative sine x. Do a good job using parentheses here so you don't make mistakes with negatives and positives. Minus the high times the derivative of the low, which would be 1 over low. And then let's just organize. How should I write a nice final answer for this bad boy? Let's go negative x sine x. Right, that negative is commutative, so I can bring that guy out. 1 times cosine is 1. That's x squared. Can I cross out those x's? No way, Jose. That's my answer for that guy. Okay? All right, let's keep rolling. And I'm gonna quit doing it the long way here. If you feel like you need to do it the long way, do it the long way. G prime of x. Let's find the derivative. Oh, you know what? There's really no product rule there, right? Oh, snap. Shame on me. But I have that square root of t, so I'm not losing anybody, that'd be a power rule, so I should really rewrite this problem first, right? T to the 1/2 plus 4 secant t. Okay, now some people will say that, well, that's a product, that's 4 times, and you actually could do that using the product rule. However, I'm going to use that constant rule that we learned in 3-3. So let's go ahead. Derivative of that bad boy. What's that? That'd be drop that 1/2 t, subtract 1, which would be a negative 1/2, right, class? Plus, that 4 is a constant, so you just like bring that out. Okay, you could use the product rule. Challenge yourself to do the product rule, and you'll get the same answer I get right here, but mine is faster, okay, because I'm using that constant multiple rule. And the derivative of secant, boom. Do you have it memorized already? That is secant t tangent t. Done. I mean, can I write it prettier? I guess I could drop that parentheses now. Don't you dare distribute that 4. We love negative exponents in AP Calc. Okay, so I guess if it was a multiple choice on the AP exam, you would choose that bad boy. All right, here we go. Rolling. Ooh, what do we have here? Oh, same type of thing. Here we go, h prime of theta. Don't even have to rewrite anything. That 5 is a constant, so it's 5. Derivative of secant is what, class? It would be secant tangent, but make sure you don't forget that theta, okay? Secant theta, tangent theta, and the derivative of tangent is secant squared theta. And some people are like, I'm going to show Mr. Tanaka my skills and factor out a secant. Why? Okay? That dude works. That works. That's totally simplified, okay? Let's keep rolling here. H prime of s. Ooh, I almost did it. Don't do it yet, Mr. Tanaka. I have to rewrite that as s to the negative 1. Right? I wonder how many of you guys were going to do it. Now let's find that derivative, which this first piece would be the power rule. Drop that dude and subtract 1. Booyah, there we go. Ooh, -10, that's just the constant. So let's just put that bad boy out in front. And then what is the derivative of cosecant s? If I'm not mistaken, it's negative cosecant s cotangent s, right, class? And then I can simplify this guy. We love negative exponents, but we want to get rid of any parentheses that can make it look prettier. Boom, done. Ooh, we've got one more. Why don't you try to hit pause and see if you can beat me with that bad boy, okay? Here we go. Hopefully you tried it on your own and you unpause. Y prime, or, right, I could go a little dy dx. I'm not going to do it the long way. Let's get right after this product rule. Now, how did I know it was a product rule? You know what kind of is a giveaway? Is these x's. Okay, so you kind of have a u is x, and v is cotangent x, right? If they both have x's in it, it's kind of like you have two functions. And when you have two functions and you're multiplying those two functions, well, that means you kind of have a product. So let's do it. Okay, how do I do the product rule? Well, I write down u, and then I'm not doing it the long way. I take the derivative of cotangent. Now, cotangent, if you notice, it's kind of a pattern. If it begins with a c, it's got a negative. It's negative cosecant squared. Ooh, it's an x, so it's an x. Plus, now I write down my v, which is cotangent of x, and I multiply that by the derivative of x, and the derivative of x is ichi. Ichi is 1 in Japanese. And then I could just write it a little bit nicer. I go negative, oh snap, that pen just ran out right now. So I'm going to try my best, class. It's going to be ugly. Negative x cosecant squared x plus cotangent x. Booyah. Problem done. I ran off that page a little bit. All right, class, that was kind of a quick, easy lesson of these trig guys. It's all about practice. Like I said earlier the other day, one of the best things you could do is AP Calc, product rule, quotient rule with trig functions. Do a bunch of problems, and you're going to be good to go in class. We'll practice this stuff tomorrow. Short, sweet video. Let's get after it.